Question number 4. In question number 4, they have mentioned there is a column which is having cross section area as a 10 millimeter, 15 millimeter. It's a cross section. The effective length of the column is given as 1 meter. In this question, our aim is to calculate slenderness ratio. I am representing with a zeta. We need to calculate slenderness ratio. So before calculating slenderness ratio, first I need to discuss what is meant by column. Keep it in mind. Column is a structural member we are using for structural applications. Structural member that always should be in vertical position. And in similar manner, it is always should be subjected to compressive loads. So axial compressive loads. Column is a structural member, so always should be in vertical position and it should always be subjected to axial compressive loads. Then only we can call it as a column. For example, you may have a doubt that if it is not in vertical position, if not in vertical position but subjected to compressive loads, that can be called as a struct. S-T-R-U-C-T, a struct we can call it as. Struct is a structural member always subjected to compressive loads but maybe in any position, inclined position, horizontal position, maybe in vertical position. Again, you may have another doubt, if not compressive load, in the case of tensile load that may be in any position, then it can be called as time. So this is the basic information regarding to this. Now, the cross section of the column is given in a rectangle 10 multiplied by 15. For this cross section, this is the centroid. For the centroid, there are two axes which are passing. One is x-axis centroidal axis, the other one is y-y centroidal axis. So here, I-x-x is given as parallel dimension is 10 multiplied by 15 cube divided by 12. I-y-y is given as 15 multiplied by, what is the parallel dimension for y-y? So 15. 15 multiplied by 10 cube divided by 12. So among these two, this is the minimum value. Why I am taking minimum value that I am going to discuss right now. So to calculate slenderness ratio, the formula is effective length of the column divided by minimum radius of gyration. K minimum can be called as radius of gyration. Radius of gyration is the distance from axis of rotation to a point where mass or area is distributed. How far the area is distributed, how far the mass is distributed. It can be called as radius of gyration. To calculate radius of gyration, keep it in mind, I minimum I am taking as a k square. So here k will be minimum because I is minimum. So from this k minimum, you can calculate the value of slenderness ratio, which is 100. So substitute here, zeta is exactly equal to effective length is 1 meter. I am taking as a millimeter, 1000 divided by under root of I is very cube by 12. Minimum value we need to consider 15. 10 cube divided by 12 multiplied by area of cross section 10 into 50. The substitute here, there you will get 346.46 will be the correct answer. It's a ratio, it doesn't have any unit. The point is, what is the significance of slenderness ratio? Significance of zeta. Just for gate point of view, this formula is very important, my dear. But in interview point of view, they may ask what is the basic significance of slenderness ratio. So as we observed, a slenderness ratio value we are getting is a more than or not more than, it's far away from 1. Generally, if you are getting slenderness ratio as less than 32 and in between 32 to 120, and if it is more than 120, then what we can differentiate? So this can be called as short column, this can be called as medium column, whereas zeta is more than 120 degree can be called as long column. So in interview they will ask how can we differentiate long columns or short columns. So don't say according to its length. If you say according to the length of the column, we should not differentiate which one is a short column, which one is the long column. We should not compare according to the length. So it should be according to the slenderness ratio. If slenderness ratios are more than 120, it could be called as long column. Less than 32 can be called as short column. If in the case of short column, it can fail by crushing because it is subjected to compressive load. It can fail by crushing. If in the case of long column, it can fail by buckling. It can fail by buckling. Buckling means this is the column that we observed. The length will tends to move in this direction. Slender we can call it as, that is the reason why buckling type of failure we can observe. If in the case of medium column, both the crushing will be there as well as buckling will be there. So in another term, we can also say the significance of zeta will predict the mode of failure. Like this also we can say, it's very important. So the zeta will predict the mode of failure, or it will differentiate columns, which one is a short, which one is medium, which one is long column. The basic significance of slenderness ratio. And this is the information regarding to columns.